Hello everyone. Today we are going to check out this new diffusion model that just launched their GitHub project code, and also they're publishing their models on Hugging Face called OmniGen. OmniGen released this research paper 2 months ago, and I haven't checked out their details before that because they had not released the Hugging Face weights, the model weights in Hugging Face, and also the GitHub project coding. And what it does is that it's using large language models alike for the Fusion transformer models to generate images, where you are able to use text to edit, modify your image, or use any image editing text keyword to edit your existing image. So what it does is that the philosophy of OmniGen, it is a unified image generation model, which, unlike other diffusion models that use additional relevance models such as ControlNet or IPAdapter, or even other additional models for the diffusion image generations. And what it is, all in one using SDXL VAE based on that to do the encoding and decoding of the noise back to image, etc. All the process using the SDXL VAE, but then the interesting part is that it's using the Phi 3 models, which are from Microsoft, that is the large language model that's able to handle the text from the user's input. Whichever you have for the text prompts, do the text editing, and it's able to train with both of that component within this new generated image generation model, which is what OmniGen created. Now, as you can see, there's some interesting part in here. For example, we have an image of this woman, and you are able to right now use the keyword image1 as representing this image as the first image input and transform this character into another new image, which shows her waving her hands in the crowd as a new generated image. So it cuts a lot of processing. If in terms of this is a successful diffusion model, if you want to create consistent characters for AI movies, if you have some works like that creating animations, you are able to just create the video scenes using just one character image and transform that into different movement actions as the new image. And maybe you can put that into video models to animate that as well for the further steps. And something cool in here. As you can see, we have 3 people in this image, whereas you see the text prompt here wants to selectively select the guy wearing the dark red shirt that is reading the book in the new generated image. So the diffusion model OmniGen will select this person as the one that we are going to create a new image where, as you can see, the results are popping up on the right side here. The dark red color shirt person appears in the library-like place and reading books in the new generated image. And something cool in here. As you can see, we have 2 different images, and you are able to handle up to 3 images per input in this diffusion model. And we are picking up the first image of the guy with yellow hair and the woman on the second image that is sitting on the left, where we will have pop out selectively these 2 people using them as new characters for our new image. Where you see in this result here looks very cool. It is going to cut out a lot of work in your image generation process. Or even if previously we were using Stable Diffusion, we were using a lot of ControlNet or IPAdapter to try to accomplish results like this. And right now we are able to do just using one text prompt with 2 of these source images are able to just transform it and generate a new image using those 2 characters. Now in here, another example using 2 images and selectively these 2 characters, the new image generated result, where you see the image of the generated result is very consistent in style, following the reference image where we have these 2 people highlighted and generated in the new generated image on the right side. And it is all using text prompt only and inputting these 2 reference images as reference image 1 and image 2. For whatever image source that we are inputting and using only this text prompt below. A man and a short-haired woman with a wrinkled face are standing in front of a bookshelf in a library. So first of all, we have defined this as the new generated image. And then we are going to reference whoever the character is in the second sentence, whereas this is the man is the main character, or the man in the middle of image 1 and the woman is the oldest one in image 2. Then select these 2 characters into the new generated image that are going to generate. And another scenario in here, as I see in their research paper, which right here you see the flowers are in these bottles or containers, and this container are just using a text prompt to describe which container we are going to select for the blue color flowers to put in for the new generated image. So this diffusion model is able to also analyze each object from your input reference image. So for example, In this 3 bottles image here, we see that the text prompt is highlighting the one in the middle of image 2. So the AI is smart enough to identify the objects in the middle and able to identify this is a bottle or, a container for putting the flowers on top of that, and is able to generate such results like this. So, with the computer vision tasks performing using Phi 3 from Microsoft Large Language Models enabled for vision and also using the SDXL VAE, it is able to create such capabilities using just one image model without downloading additional ControlNet or IPAdapter. In the image generation workflow or pipeline system, this tool enables photo and image editing in various ways. Primarily, it allows you to remove items from an image. For example, in this case, we see the earrings removed from the newly generated image, and the color of the Coke glass transformed to blue, which is highlighted in the right-hand image. As you can see, the bottom image uses the same pose as the woman on top, allowing it to identify the pose reference and generate a child reading a book in the same position. In the lower left, we see 3 people as the input reference image, with only the middle person selected as the new generated image on the lower right. This example combines the character in the middle with the young boy reading the book, creating a new image where the man sits beside the child as he reads. It's amazing that this diffusion model can accomplish all this with just text prompts. Plus, you can input up to 3 images and handle all the objects within those images for your next generation. Next, we'll check this out on GitHub, where you can download and run it individually. This tool includes a web UI using Gradio. After installation, you'll be able to run it offline, locally on your machine. Additionally, I've seen ComfyUI custom nodes for OmniGen. Note that some errors and conceptual issues exist in these custom nodes, so after downloading and installing, some manual editing is needed to make them work. In this tutorial, I'll show you how to install and set it up to create similar examples. So let's dive in. First, we'll install this by using git clone and entering the OmniGen GitHub project link. Next, we'll use conda create and specify Python version 3.11. Note that version 3.12 has issues with compatibility. Keep it set to version 3.11, press yes, and once created, activate conda. You'll see the environment name appear in brackets before the command prompt. Next, we'll use the pip install y command to install all necessary components for our conda virtual environment. Once successfully installed, we'll see the setup completion message. Then, we'll run the Gradio setup by typing pip install Gradio. This starts downloading all the Gradio files required for this GitHub project. Once the download and installation are complete, you can run the web UI for this project and start experimenting with OmniGen using their GitHub project web UI. The next step is to type python app.py. The first time it runs, it will start downloading all model files from Hugging Face repositories, including the VAE and the OmniGen Diffusion models, which you can see in the Files and Versions tab here. These files are essential if you want to use ComfyUI or other Diffusion web UI interfaces later. If you don't want to use their default web UI system, you can move these model files from your Hugging Face download folder for alternative setups. For example, in my Windows system, I first run the download in the cache folders of Hugging Face. Once downloaded, I locate the folder's path and transfer it to another system where I plan to run it later. For the initial setup, we type python app.py, which will download the model files. Also check out some component versioning, as some may need adjustments to ensure compatibility with your system. You might need to modify a few things. For instance, in my setup, I needed to change the version number of NumPy. When you load the URL, the local IP URL, you'll see that the OmniGen web interface settings can handle up to 3 images using the image-to-image features. Some example images are provided below. This page mirrors the Hugging Face Space demo page exactly, and I'll include the link in the description below. If you encounter issues installing it, you might want to try it directly on Hugging Face. Now, let's go through how to install the OmniGen ComfyUI custom nodes. This is the original OmniGen ComfyUI custom nodes repository from AIFSH. There are some issues in this repository that we had to fix, mainly due to problems in the initial .py files which interfere with loading the text prompt custom nodes. I'll demonstrate this first, then show you how I fixed it. I've created my own OmniGen ComfyUI custom nodes repository with a fixed version of this GitHub project. To install it, first copy the link here. You can use the ComfyUI custom node manager to install via the Git URL by pasting it, but I prefer using the command prompt for more control. In the command prompt, start by typing git clone and paste the project URL. After downloading, you'll need to install the components in requirements.txt. I've already done this, so I won't go through each command, but if you don't have the components, you'll need to run pip install r-requirements.txt once in the command prompt. After that, restart ComfyUI, and I'll explain why I mentioned issues with the original OmniGen ComfyUI nodes from AIFSH. We've encountered errors in this repository where fixes weren't applied before it was published. Let's go over an example. When you load the ComfyUI custom nodes example from the doc folder in this GitHub project, you'll find a subfolder with example workflows. I'm using the t_i2 i_workflow.json file here. Just drag and drop this JSON file into ComfyUI and it should load the workflow files. You'll see that the image loads without issues, but the text prompt has some problems. On the project's GitHub page, many users report issues with the text prompt, and the author has added code for a bug fix. This fix now allows the text prompt to work properly with certain Python conditions, which is why the original custom nodes version consistently encountered errors that hadn't been addressed. I've created an updated version by forking the GitHub project to my own repository. I'll share this link so you won't encounter the red box error for the text prompt anymore. In my updated version, I've modified the initial.py files, resolving the text prompt error. Now, you can use this without any problems. First of all, if you've already downloaded it quickly without following my tutorial, I suggest deleting that version. Just highlight the folder, delete it, and reinstall the one I posted in the video description below. I forked that GitHub project and fixed the bug. So you'll go back to the command prompt window. In the command prompt, type git clone and use the link I'll provide in the video description. You can download this version, run it again, and if you need to install the components in requirements.txt, go ahead and do so. After downloading, return to ComfyUI and restart it. Once restarted, you'll see that the text prompt works without issues. This text prompt node is specifically designed for the OmniGen custom nodes package and can handle text input here. The system uses a unique data type for text that isn't compatible with other text types. I'm not sure why the original programmer did it that way, but it is what it is. At least with my fix, you can now work with the text prompt without encountering the red error box. Now, here you see the OmniGen nodes, which combine all the necessary sampler settings for OmniGen. It's a very simple design. Just one node that can process text prompts while handling 3 images with the diffusion model, generating output results. I'll go through some examples using OmniGen custom nodes, demonstrating how they work. In some cases, the results look great, while in others, certain poses or features may not replicate perfectly. To improve those, we may need to adjust settings or seed numbers. Let's check out some examples now. In my first example, I'm using a landscape image with a river and a woman, a common setup I use in AI demos. Here, I've set the dimensions to 1024 by default. The text prompt describes the woman in image 2 appearing on the riverside of image 1. This setup uses both images in combination and composition to generate a new image. The resulting image is flipped, but it doesn't exactly match the landscape in the original image. The diffusion model uses the compositions of both images to achieve this effect. In the second example, I'm using another AI-generated image to change the woman's clothing to a leather jacket and adjust the image's dimensions. Here's the output image, where you can see the woman is now wearing a leather jacket with new characters alongside her due to the different dimensions. I'm using a 1024 dimension setting. Let's try something fun with this image. I'm using a character, a female figure sitting in a washroom toilet. Let's see how the output image compares to the original. Here's the combined image using the text prompt and reference image. The woman isn't an exact match, as the body proportions differ slightly, but the model replicates the outfit and characteristics well, along with the washroom toilet setting from the text prompt and the altered image dimensions. This process introduces extra content in the output image. Now let's explore virtual try-on features, which I found particularly interesting. In this example, the woman is wearing a red tank top with a pattern on the top surface. I'm using the second image to place the clothing onto the woman in the first image as her outfit. This will also change the background in image 1, resulting in a different look. Here's the output image. As you can see, the woman is now wearing a red tank top with the original pattern from the source image. I simplified the text prompt here to focus on changing the outfit for a more natural look compared to the previous, more complex prompt. The pattern is clearly visible and identical to the Amazon demo image I used as the source, achieving a virtual try-on effect that looks even better than what I've shown in previous videos discussing Kohler's diffusion models and Kohler's IPAdapter. OmniGen has strong potential for various image editing tasks, all managed through simple text prompts. I hope this inspires you, and I'm sure some of you already have ideas you're eager to try out. I'll see you in the next video. Have a nice day. See ya!